Good afternoon everyone. Now the next topic how to convert any binary number into hexadecimal. As in the previous video lecture, I have told you that how to convert any binary number into decimal and how to convert any binary number into octal. So today my discussion is on the topic that is the conversion from binary to hexadecimal number system. So let us start. For example, as you have in the previous video lecture, as you have seen that in binary to octal conversion, I have told you to make a group of binary digits, but into the sets of 3 you have made it. Okay, but now you are converting one hexadecimal number into binary. So in case of hexadecimal, you have to represent the binary number into 4 digits. Okay, means into the set of 4 you have to represent it. So that is why what we will do in case of this, we will make the group of binary digits but into the sets of 4. Okay, this point is important, so you can underline it, like in case of hexadecimal, in case of binary to hexadecimal conversion, what I have to do, we have to make the group of binary digits but into the set of 4. Okay, so I'm just telling you that how we will make one table to convert any hexadecimal number into binary. Okay, so you can make this table into your notebook. For example, as you know that hexadecimal number starts from 0 and it goes up to 15. So first of all, I'm taking the number from 0 up to 7. Okay, so first of all you just make the table of these numbers. So if I'll check the binary representation of these hexadecimal number, then the binary equivalent of these numbers are like this. Like the binary equivalent of 0 is 4 times 0, and the binary equivalent of this one is 0001, the binary equivalent of 2 is 0010, the binary equivalent of 7 is 0111. Okay, so if you want to check whether the binary representation for these numbers are correct or not, then the same way or the same procedure method you can apply for that. Like first of all, you have to start from the least significant bit, means from the rightmost digit you have to multiply this number with 2 to the power. Okay, so we will do that. So you just proceed for that. First of all, I'm calculating this one. So 0 into 2 to the power 0 plus 0, this 0 into 2 to the power 1, then 0 into 2 to the power 2 plus 0 into 2 to the power 3. So the summation of these 4 digits will be equivalent to 0. That means this one is correct. The binary equivalent of this 0 is correct. So just like that, I'm just checking the binary equivalent of this one also. Okay, so we will start from the least significant bit, so that is why I am multiplying this number from the least significant bit. So in the least significant bit I am having 1, so that is why I am multiplying this number with 2 to the power 0 plus 0 into 2 to the power 1 plus 0 into 2 to the power 2 and plus 0 into 2 to the power 3. So the summation of this or these 4 numbers will be 1. So the hexadecimal representation of this set is 1. So just like that we can perform for 2, for 3, for 4, for 5, for 6 and for 7 also. Okay, in case of 7 you can check, like first of all 1 into 2 to the power 0 plus 1 into 2 to the power 1 plus 1 into 2 to the power 2 and plus 0 into 2 to the power 3. So if we will calculate these numbers, so you will get in the summation part you will get 7. Okay, you just check it, like it will be 1, it will be 2, so 1 plus 2 will be 3, then 2 to the power 2 is 4, that means 4 plus 3 it will be 7 and this part will be 0. That means the summation of these 4 digits is equivalent to 7. Okay, so this is, that means you can say, you can apply the shortcut, means if there is one number in case of hexadecimal, just like 45 means 45 is given, and in the base part it is written that this is one hexadecimal representation and you have to convert it into binary. So directly you can write the answer, means you can write 0 1 00, then 0 1 0 1. So this is the binary representation of 45, and the base part you will write 2. Okay, got my point, what I mean to say. Okay, so now you just check for the next next numbers, like as the range of hexadecimal starts from 0 and it goes up to 15. So basically from the 10 from the digit 10 we just represent all these numbers with the help of character. So our digit 10 is representing with the help of this A, then 11 is representing with B, 12 is representing with C, 13 is representing with D, 14 is representing with E, and 15 is representing with F. Okay, that means the range is not over yet. Okay, so we are taking some more digits in case of hexadecimal. So the rest of the digits I am taking here. So you just check it, like I have written the binary equivalent. Okay, so you have to learn it, or you can you have to understand it, after that you just learn it. Okay, so I'm telling you that like if you just check it, like the whether this binary equivalent is correct or not, so you can check it. Like you will start from LSB digit, as I'm telling you again and again. So you are just checking it, like 0 into 2 to the power 0 plus 0 into 2 to the power 1, 0 into 2 to the power 2 plus 1 into 2 to the power 3. So what you will get in the answer part, these 3 digits will be 0. Only this part will be like equivalent to 8. That means the total summation of these 4 digits will be 8. Correct? Just like you will perform for 9 also. Okay, and same procedure will be applied for this A. A means 10. So you just check it, like 0 into 2 to the power 0 plus 1 into 2 to the power 1 plus 0 into 2 to the power 2 and 1 into 2 to the power 3. So what you will get, this will be 0. 1 into 2 to the power 1, that means 2. This part will be 0 and this part will be 8. That means 8 plus 2, it will be equivalent to 10. And 10 will be represented with the help of this alphabet or with the help of this character, that is A. Okay, so in case of hexadecimal, the 10th digit will be represented by A, 11 will be represented by B. So just like that. So that means if there is one example that you have to convert any hexadecimal number and the number is like 9D. Okay, this is one hexadecimal number, that is 9D, and you have to convert it into binary. So what will be the binary equivalent? So for 9 you know that we can write 1001. Okay, so directly you can write it, that the representation, the binary representation for 9 is this, and the binary representation for this D is like D is equivalent to like 13. Okay, so first of all you will write like D is equivalent to 13, then after that the 13 is equivalent to this binary number, that is 1101. Got my point? So now what you do, you just check the example, like one by one. I have told you that the summation, I have taken the summation part also here. Okay, you can check it from this video. So I'm taking one example, just like I have taken like binary to hexadecimal, and this is one binary number which is given to you, that is 11100101. So from what you did, you just made the group of binary numbers in a set of 4. So from the LSB digit you will make the group. So from this side I'm just making one group, and this next group will be this. And if you like feel that there is only a set of 3, then from the most significant bit side, means from the left hand side, you can add 0. Okay, as we did in the case of binary to octal also. So if you check the hexadecimal equivalent of this number, then what will be the hexadecimal equivalent of this number? So you just check your table, it will be equivalent to 14 and this number will be equivalent to 5. That means for 14 what we write, in a case of hexadecimal, we write E for this 14. That means the hexadecimal representation for this binary number will be E5. Okay, got my point? I think this is clear. Now what you do, you just try to solve these practice questions. These are the practice questions. You just solve it by your own. First of all, you just understand the example which I have given you, which I have told you in this video lecture. First of all, you just try to solve it by your own. After that, you just do practice of all these questions. Okay, and if you got the answer of all these practice questions, then only you just check your answers. So these are the answers, or you can say these are the hexadecimal equivalent of these binary numbers. Hope this part or this conversion is very much clear to everyone. So do practice at home so that in the midterm examination you can do well. So thank you very much. Thank you so much.